A cafeteria sells sandwiches. The graph represents the proportional relationship between the number of sandwiches purchased and the total cost. So here's the graph, and then it says which table represents the relationship shown in the graph. This is a very, very tricky problem, but the way we've always approached things with graphs is that we always try to find a point that we know on the graph, and in this case, the point I can definitely be sure of is this one right here, and that connects to 20 and 50. Okay? So, if I look and I put sandwiches, sorry that this is written so small, and cost, and if I'm writing this down, you're writing down the same thing. If 20 sandwiches cost $50, we want to find how much one sandwich would cost. The way we're going to solve that is once again by using cross multiplication. 20 times n equals 50 times 1, which is 50. Recopy the n, recopy the 50, and then divide by 20. 20 goes into 50 2 times, with a remainder of 10. There's a couple of things you can do here. One way would be to make this 10/20ths and reduce it to 2.5. How much money, when you say 2.5, how much money is that? If you said $2.50, you would be correct. So that means that one sandwich costs $2.50. Alright? So, steps are always find a point you know, find the rate, and once we find how much one is worth, we can just create our table by figuring out our multiples of 1 and $2.50. Okay? So at this point, I'm looking at a bunch of different tables. There's only one table here that I see that has 1 and $2.50, and that's this table right here. Now that doesn't mean that it's the right answer. I need to check that the multiples of 1 and the multiples of $2.50 are in both rows. If I roll my 1s, 1, 2, 3, 4, 5, that works. If I roll my $2.50, $5, another $2.50, $7.50, $10, and $12.50, that one seems like it works. Okay? Now, a few other things. If you look at letter B, so there's a couple of points here. This is a ratio table, but if I take a look at any of these points, so let me just take this point right here, 5 and 10. If I look at the graph for 5 and 10, at $10, it doesn't exactly hit 5. Again, at $10, it doesn't exactly hit 5. It has to exactly hit it for it to work. So letter B is wrong. If you look at letter C, some people think of it and say, oh, this is definitely a ratio table. However, it has the same exact wrong numbers. 5 sandwiches is $10, not according to the graph. And then letter D is completely on crack because it rolls the 5s, but if it's a ratio table, it would roll the 11s as well, and this doesn't even roll the 11s. This one's not even a ratio table. The correct answer to this problem, and yes, this is a difficult one, but if you follow the same steps every time, you have to look closely and you will figure out that the answer is A.